So without further ado, let's get started. The first title of the talk today is How Adaptive AI Solves Big Challenges for tinyML. And our speaker is the Chief Executive Officer and co-founder of Latent AI, Jags Kandasamy.
Thank you,
And
Stephen.
I'll turn it over to you now, Jags.
Thank you. I could be the chief co-founder.
Yeah. They're the big chief.
Yes. All right. Hey, guys. Thank you for the opportunity here and welcome everybody to how we can help adaptive AI solve the big challenges for tinyML. I will, there we go. So Latent AI, we are on our mission to simplify and accelerate AI development for anywhere in the edge continuum. What do you mean by edge continuum? We've all talked about tinyML being the source of the data, right? When analog meets digital, that's where tinyML comes into play. All the sensor that does the conversion is where the edge starts. For us, when we look at edge, it doesn't just start and stop there at the sensor level. It goes all the way up into the core of the cloud or core computing or edge of the network, if you want to call it, right? Each one of these layers are built differently with different compute infrastructures. The tinyML side, where we are talking mostly, is all on microcontrollers and very tiny microprocessors and ASICs in that side. As we go up, you have different gateways, different closet computing, different small servers and stuff that do different levels of computing as you go in, and then you go into the HPCs into the cloud area. We help build your models right-sized for the right target, and then orchestrate them along the way. That's what we do here at Latent AI. I am there pictured with my intelligent co-founder. He's the most intelligent one in the organization. Sek Chai. Sek has been, I think you guys probably would have listened to him this morning at the keynote at 9 o'clock. He talked about adaptive AI in more technical terms. I'm more of the business guy. I just love to talk and I make money talking. So that's who I am. I ran another startup earlier called AutoSense, where we had automated human hearing. So where we listen to sound and identify events within that. And that company was acquired by Analog Devices, and they were making sensors out of our software stack. And that was my foray into edge AI. And I think even before tinyML as a concept existed, we were doing something along that work. Just to highlight some of the journey so far that we've taken, we were awarded the IoT World Startup of the Year award last year. We were selected by Gartner as one of the top 10 edge AI companies. We were also recognized by STL Partners, which is a big telco consulting organization or an analyst organization. They listed us as one of the edge computing companies to watch. And of course, one of the biggest accolade for us is we were part of the 20 finalists at TechCrunch Battlefield. Thousands of companies that applied globally, and we were one of the 20 that got shortlisted, and we were able to present in a global stage. Okay, now that's who we are. So why are we doing this? If you think about it, and we just touched on the subject of analog to digital conversion. If you remember back in the day, like even some 10, 15 years ago, most of our digital conversion required some sort of a human input to happen, right? You were in front of a keyboard, you were scanning a document, you were taking a picture and all of that stuff. That's how most of the analog to digital conversion happened in the real world. But today, with with Moore's law and the cost of computing going down, cost of chips going down, everything is becoming electronified, right? That's the word I'm using. So everything has become electronified, and we call this the IoT, right? Internet of Things and Devices. So the number of devices just exponentially grows, has been growing the past for a few years, and it's going to hit like 75 billion devices by 2025. Now, let's take another metric. We had 22 exabytes. All of the internet combined in 2002 was 22 exabytes. Today, we generate the data every 4 hours. And that number is going to shrink. The number of hours is going to shrink because the number of devices is going to increase. Now, all we can do is try and take this data up to the cloud and do the analytics there, apply AI processing there. But what if we are able to push that down, reduce the cost of transportation with the reduced cost of computing available? Why can't we allow AI models to be run at the different levels of the continuum? That's what we are proposing. And if you look at current solutions, they are like, focused over there or focused over here. There is no continuous solution available from that perspective. So our proposal is, we're allowing teams to build once and deploy the model many times. You can take the same model, build it for tiny space, a small or a medium size or a large, and you can deploy it along the way and orchestrate it accordingly, right? You could have an image recognition model running on the camera. The image recognition could be just a tiny model that does human detection. If you arm your home security and leave, you want to make sure only when a human is moving inside the home and you're not expecting anybody, you want to be notified and you want the cops to show up, right? Like emergency services being called. If your cat is moving around, you don't want that to be notified. So here in this case, we can actually apply a tiny model, a human detection model, which we've built at like 83 kilobytes on a MobileNet V2, quantized to 4 bits and 2 bits actually. And we can run that on that level. And once that image is identified, you can push it up to the next layer of compute to figure out, hey, can I identify who that person is before I make a determination of triggering what the next workflow should be. So facial recognition and other activities could be triggered on different layers. So that's basically our proposition of build once, deploy many times. So this is the concept of adaptive AI, taking that the adaptiveness and switching models around in different compute layers. All right. What do we do, right? We are helping the enterprise edge. For example, we were talking to a customer, a quick service restaurant customer. They had done their pilot in doing quality controls on the food process that they're doing. And they had done the pilot on a high-end GPU server. Now, if you look at that and if you were to explode that into 2,000, 3,000 locations, that server cost alone will be multiple tens of thousands, and it's going to be very, very expensive for them to deal with that. So they said, like, all right, can we apply these models to run on a smaller box, which is already existent in the restaurant, in the back office? We are helping them solve that problem, and also that one is running on an x86 platform, and another box they want to introduce, which is also a low-cost box, which is going to be on a GPU. So there we have a heterogeneous environment, and we are trying to unify that and provide a homogeneous outlook for the customer, so they can take their model, use our tools, and not worry about what compute layer that they're going after, but be able to target and make it simple enough for them, right? So that's basically what we are able to do. Our solution is hardware agnostic. We provide higher inference speed. We are energy efficient. And of course, with our quantization function, I'll talk about that in the next slide. We are able to bring some cost efficiencies to this equation. Okay, so what do we do? From our adaptive AI approach, we are an SDK provider. We provide a set of tools to our customers that they can download, and in a container that they can bring into their own workspace and work with their data and models. We don't get to see the models. We are not a SaaS provider. We don't, from a privacy point of view, we are not bothered with that, right? So our functions include distill, where you can take a large model and be able to pull smaller models of same classes or similar classes together, adapt the ability to choose which set of parameters to run within a network model, and then compress where we are able to quantize models and also apply other ML techniques, compressing models from 32-bit float to 8-bit integer and below. We have taken models all the way down to 2-bit and 1-bit as well, asynchronous mode, and then we are able to then compile these models into your target hardware, right? And then on the run side of things, we have the latent runtime engine, which is able to orchestrate multiple models within the same substrate, and also able to communicate with other latent runtime engines running around in the network and be able to communicate with each other and move models and move inferences as required. And also we are able to help deploy these packaged models. And security perspective, today, if you build a model and you deploy, if there is a man in the middle attack and somebody interjects it and changes your weights and introduces some bias or something like that, you may not be able to catch it while it's running. We have technology that'll help you prevent those kind of attacks and secure the model that's deployed. And then towards the end of it, we all know, folks here are very familiar with deep learning models. We all know model that is being trained on data collected 6 months ago will continue to grow staler as new data comes in. How do you manage this? How do you monitor what's going on there, collect new information, and be able to train and feed it into this cycle and keep the model fresh? And that's what our connect and manage applications do, right? This is how we bring about solutions to tinyML as well as along the edge continuum. So to show some examples here, right? So this is something that we did with Sentient, and Sentient, as you guys know, is the winner of the Hardware of the Year for tinyML. We're very proud of Sentient as a partner and being associated with them, with Steph and Sean and Malik and all these guys. So here, our quantization is able to compress a people detection model, a person detection model from 1.4 MB to 81 kilobytes to 81, about 17x in memory size reduction, right? And then if you look at the same thing when you're running from an inference perspective, we are using 92x less energy than the same model running on a GPU or even on a Raspberry Pi, right? That's the power of the Sentient processor and our ability to get the model size down and fit into the Sentient architecture, right? So, and then on the right side, you can see the comparison of different models, not just the people detection model, but different other models that we've seen between our baseline and the latent AI speed inference per second, right? We've shown between 2 and 6x speed up, and we are always working on increasing that. We have an excellent set of team around us in latent AI that we are always pushing the envelope, trying to get more speed up. Okay. All right. I'll talk about three use cases, case studies that we're working with, and these are our customers. So one is we're working with an automotive OEM where they wanted to apply object classification, object detection on the backup camera to enable automated driver assist, right? So this is basically enabling automated braking and help the driver. So here, the customer wanted a MobileNet model running at 30 frames per second on an A53 class processor. We were able to achieve that, and they are working now on inputting their models, and we are also looking at pushing that boundary further into 40, 45 frames per second as well. Customers extremely happy, and they are going through their tests right now. The second model, use case is more around the context-aware inference orchestration, where the edge continuum comes into play, right? I'll bring that around with the computer-aware side as well. So this is a CPG, consumer packaged goods company. They normally rent retail shelf spaces from retailers, and they need some sort of an audit mechanism to make sure that their products are displayed properly, they are being replenished at the appropriate time, and also being able to monitor how the competition is doing. These guys built a large monolithic model and ran it in the cloud and tried to communicate it using a mobile back and forth. It did not work very well for them. So they came to us, and the strategy is around how do we talked about distill, right? How do we take this large model and create smaller models of similar classes? So think about all face products into one model, all cleaning supplies into one model, all paper products into another model. Now, you've got these independent models. Now we can take them through the compress and compile workflow, and you have smaller models that can be put into the mobile device. Then you're able to orchestrate them. We have a controller network. Sec talked about this in the morning. We have a controller network that can scan the horizon, looking at it. Oh, looks like I'm in the paper aisle, paper product aisle. I'm going to run only the paper product model. I don't have to run the face product model because I know face products are not going to be here. This is more application specific use case, right? So we are able to orchestrate in that scenario. The last one is the compute-aware inference management. We are working with the telco, trying to help them establish and showcase how the mobile multi-axis edge compute platform could help in scaling AI inference workloads. In this, a doorbell camera is running a human detection model. And only, if anybody here is using Ring doorbell, you all know how many false positives you get. Anything moves in front of it, you get a notification. One of our advisors had 600 some notifications in one day. There was a bee trying to enter the camera hole, thinking that was his habitat. He was trying to enter that, and every attempt he made, there was a notification coming out. So anyway, we can solve that by putting just a tiny model that does human detection on that edge device. And once a human is detected, then you can take the clip and send it up to the next layer of compute. It could be a gateway in your home, or it could be through a 5G connection to a computer infrastructure running at the telco's area. And you could do facial recognition there to identify who the person is. And then you can determine what posture or pose that they're doing to determine whether it's safe or what are their next workflow to initiate. So that's where we come into the compute-aware inference management, right? So last slide and one small story I've got to share. So we presented this morning at the as a keynote. Sekchai presented that, and then we have Seti Gamari. He's going to be doing a paper at the symposium on Friday. How quantization guided training for compact tinyML models, right? How that works. So that'll be good. So last 1 minute thing. So I was reading Spy in Moscow Station a few months ago, and I was appalled or like excited by the application of tiny electronics and how tinyML could save a lot of things in this area, right? I'm not going to get into details of this, but this for me is my encounter of first edge computing application in a spy situation. If you're interested, go read this book, Spy in Moscow Station by Eric Hestline, former NSA research director. So with that, thank you.
Thanks, Jags. That was very interesting. Thank you.
Again, just a quick shout out to our sponsors. Bear with me for 1 minute. We have different categories. We have executive sponsors. First one being ARM. Then we have Qualcomm. We have Samsung. Platinum sponsors. Ada Compute. Lattice Semiconductor. Gold sponsors, BrainChip. Babel Labs, DSP Group, Edge Impulse, EMSA, Gray Matter Labs, Greenwaves, Hymax, Imagimob, Latent AI, Maxim Integrated, Quixo, Reality AI, SenseML, Silicon Labs, Sentient, Google TensorFlow, XMOS, and lastly, silver sponsors, Edge Cortex, Hotchi, and Synsense.